Welcome to another PhD session. Today we are going to discuss a problem named wave pattern. So let's move to the description part. We are given a linked list of unsorted integers with unique values. We need to check that it forms a wave pattern or not. A sequence is said to be in wave pattern if it is increasing and then decreasing alternatively or vice versa. Okay. So for example, if we have linked list 4, 7, 2, 8 here. Okay. So this represents a wave pattern as shown below. Okay. So for 4, the next item is 7, which is greater. The next item is 2, which is smaller. I mean, all the alternate items are the greater, increased means greater than or decreasing or smaller than. Okay. That's how it is forming the wave pattern. Okay. So we just need to tell that if a linked list and unsorted linked list have the wave pattern or not. Okay. So let's say that the given first. We have an unsorted linked list and we need to tell if it is a have it if it have a wave pattern or not. Okay. And if a sequence is increasing and then decreasing alternatively or vice versa, then it have a wave pattern. That is, let's take a sample input. Okay. Here. Okay. 47365. So 47365 is our linked list. Okay. Let's start with 4. It's my first item. So I've written it as it is. Okay. And then as 7 is greater than 4, so I have marked it with a red color and in upward direction. Okay. Then next item is 3, smaller. That's why downward arrow and blue colors. Okay. When the change of color. And then 6 is next item of 3 and it is greater than 3. So up in upward direction and red color. Now 5 is less than 6, downward direction and blue color. Now if you can match it, isn't it forming a wave pattern, right? This is the wave pattern, right? So that's why this sample case have the wave pattern. Let's check another sample input. What was another sample input? 2, 5, 8, 9, and 1. Okay. So 2, 5, 8, 9, 1. Again started with 2. 5 is greater, so in upward direction and red color. 8 is greater than 5 in upward direction and red color. See, it was supposed to go down because it is alternate to 5. Okay. But it is greater than 5. It is alternate and it is greater than 5. So it is again going upward. So this can't be a wave now. A wave should be like this. Alternate thing is going down. Okay. So that's why therefore false. It doesn't have a wave pattern. Okay. Fails here and not a wave pattern. You can see output is false also. And for the first sample case, it is true. Okay. That's why. Now what should be our approach? See, whatever item I am currently at in the linked list, okay? I mean, I should be at some node to check, right? So whatever item I am currently at in the linked list, I can check my next item only, right? Because, and that is if my next item is greater than me or less than me, that's all I can check if I'm at some node, right? Like here, if I'm at 8, I can't check what was previous to me. It's a singly linked list. I can check this one only or this one, okay? That's why, because it's a singly linked list and you can move in the forward direction only. You move forward only in singly linked list. Okay. So I need to find a way to remember my previous item. I mean, information about previous item. That is, if my previous item was, I mean, if I am greater than or smaller than my previous item or not. Okay. That's what I need to remember. So that's what I've written here also. If my previous item is greater than me or smaller than me. Okay. So to remember this thing, we can use a flag. Okay. You can use a flag. Flag is nothing but a kind of variable. Okay. So for this, the linked list have at least 2 items, right? What are we going to compare? Even to compare, we need minimum 2 items. Okay. That's why 2 items. That is initially for second item, we will initialize the flag. Okay. Like what is previous to second means first item. That is, if second item is greater than first item, then initialize the flag with 1. Otherwise, flag 0. Then you must be asking if second item is equals to first item. That can't be the case, okay? Because in the question, it is already written that it is unsorted integers with unique values, okay? So none of the integers are going to be repeated. So equal to condition is not there anyway, okay? So if my second item is less than first item, then flag will be 0. And if my second item is greater than first item, then flag will be 1. That's my initialization part, okay? Now, let's see here. These are two nodes, 4 and 7. So if I'm at 7, okay, and I'm checking if 7 is greater than 4, yep, true. So flag equals to 1, okay? Now moving on and traversing the whole linked list further, okay? Let's see. I was at 7, flag equals to 1. Now what will I check? Traverse further and check if the next item is greater or smaller. Like 3 is greater than 7 or smaller than 7, okay? 3 is greater than 7. No. Then what will happen? So if next item is greater and flag is also 1. I mean, if the case was instead of 3, it was 8, okay? So 8 is greater than 7, true, okay? And the flag is already 1. Flag is 1 if I am greater than my previous item already. Okay, means 7 was greater than 4, right? And 8 is greater than 7 also. So what will happen? Means 4, 7, and then 8. So it's not a wave condition, right? Because the arrow should come down after 7, not go up, okay? So that's why what will happen? That we will return false, and as previous was also greater, so therefore no wave pattern, okay? But here 3, it is smaller, okay? Like if the next item is smaller, 3 is smaller, and flag is 1. Flag was 1, then what will happen? It's a good condition because 4, then 7, and 3 is smaller, then the arrow will go down, okay? So it is making a wave condition. So at that point, we will put our flag equals to 0, okay? And further move on to next is now my current will be this, and I will check my next item, okay? Let's try it here, okay? Like currently I am at 5, okay? So my next item is 8 greater than 5, true, okay? And flag is already 1, means it was going like this. Now it is greater, so it will go like this. So therefore return what false here in this case, okay? This was my second sample test case where it was giving me false. Remember the answer now? In the sample, this one, it was false. So that's why it is false, okay? Because it is greater, my next is greater than current. Next is greater than current. And flag is also 1. Therefore return what? False, okay? Let's come to pseudocode part. So step 1 will be about, the prototype, okay? And initializing the flag. So check wave is my function. I'm passing head. So if head dot next dot data means I'm checking for the second node. If my second node's data is greater than my first node data means head dot data, then I will initialize the flag equals to 1. Okay, means this is my initialization. Okay, flag equals to 1. Okay, in the else part means if my second item is with my second item, my arrow goes down means flag equals to 0. Okay, and if it went up, then flag equals to 1. So these are the two conditions, okay, at the initialization. Now step 2. Step 2 what? Now after accessing these two, what I'm doing, I am going to traverse from here by checking the next neighbors, okay? Next. So that's why I'm putting my temporary variable at the second item, which is head.next, okay? Then I'm running a while loop to traverse all the items, okay, one by one, all the nodes, okay. If its next is not equals to null, okay, so it will stop when I am at the last item, okay. So if temp.next.data is greater than temp.data, okay, means if my next node's data is greater than my current node, and if at the same time flag is also 1, means current node's data was greater than previous node also, okay. So what will happen? It will fall because this is this condition. No way, okay, therefore false. Otherwise, if that's not the case, means flag was 0, then I will put my flag equals to 1 and move on, okay. And this is the vice versa condition, okay, where it was going like this and again it went down, okay. So what will happen? Return false. And if that's not the condition, then I will put the flag 0 and move on. How to move on? Making the next equals to current, okay. So that's why temp equals to temp dot next. I'll show you how. And if my while loop completely terminates, okay, then that means I have a wave pattern and it will return true, okay. If it is not a wave pattern, then in between it must have returned false at some point, okay. But if it is reaching here after completing the while loop, means it is going to return true only, okay. So let's run for this. So initially, this is my head dot next, okay. So what will be my flag? Head dot next dot data is greater than head dot data. 7 is greater than 4. True. Therefore, flag equals to 1 and temp equals to head dot next. So temp will be here only. Okay. Let me take another color. Temp will be here only. Now what I'm checking. Temp dot next dot data is greater than temp dot data. Okay. What is temp dot next dot data? This is 3. So is 3 greater than 7? False. Okay. Means I will lie here. Okay. So if flag equals to 0, no, because flag is equals to 1 initially. So what will I do? I will make flag equals to 0 and temp equals temp dot next, means I will make temp here. Again, I will check. If temp dot next dot data is greater than temp dot data, means 6 is greater than 3, true. Okay. Means I am here. If flag equals to 1, no, flag was 0. So what will I do? I will make flag equals to 1 and move my temp variable from here to here, okay. Now what will happen? I will again check temp dot next dot data. So what is it? 5. Is it greater than 6? No, means I am here. What is my flag? Flag is 0? No. So what will I do? Flag equals to 0 I will put, and what will I do? I will move my temp variable. So instead of here, it will move to here, okay. It will move to here, and what will happen? My while condition temp dot next is not equals to null, but my temp dot next is null, so terminate. Okay, when my while loop terminates completely, okay, means I have traversed the whole list completely and it formed the wave pattern. Otherwise I would have returned false at some point, okay, but I have never returned that. That's why I will return true now. Therefore return true. Okay, similarly here in this example also, 2 is here, 5 is here, head dot next is 5, head dot data is 2. So is 5 greater than 2? Yes. So flag equals to 1 and t will be here, okay. Now moving on in the while condition. Temp dot next is not equals to null, right? So temp dot next dot data is 8. Is 8 greater than 5? True. Is flag equals to 1? Yes. F equals to 1 also. This is also true. Therefore, return what? False. Hence no wave pattern, and that's what the output is also. Okay, we have already saw that. Yeah, so I hope you understood till here very well. Okay, and I am leaving the edge conditions for you people, like if head equals to null, and if there is only one node. Okay, write these include these edge conditions in your code. Okay, I'm leaving it for you. So that's all for this session. Thank you everyone. We'll meet in next session.